Hello everyone! In this seminar, I will introduce you to the overview and usage of DOE and Simulation Manager. So, let's take a look at the advantages of RecurDyn DOE. The first advantage is that you can set the DOE levels via intuitive UI. Easy design, variable creation, and performance index settings are also another advantages. Thirdly, the analysis with multiple design variables and performance indices are possible. In the DOE dialog box, there are sections to set the minimum and maximum values, and you can intuitively see each design variable and the number of design variables. And the simultaneous analysis of the DOE analysis cases is possible using Simulation Manager. The DOE analysis via Simulation Manager, which will be explained in more detail later, enables a significant analysis speed improvement. In this chapter, let me introduce you the basics of how to use DOE. The example model is a pinball model, as you can see here. To briefly explain the model's situation, ball 1 is pushed by spring. After ball 1 makes contact with ball 2 passes through the obstacle on the right and makes contact with ball 3. You can check the analysis results through the result sheet in the DOE dialog box. First, if you see the rightmost columns of the table, you can check the results of the performance indices. The blue highlighted value is the minimum value. The red highlighted value is the maximum value. In this chapter, we will focus on the overview and usage of a Simulation Manager. Briefly speaking, Simulation Manager enables running multiple simulations required for DOE simultaneously. Simulation can be performed simultaneously as many as the number of licenses the user has. In addition, using a multi-core processor can significantly reduce the time on DOE with the Simulation Manager. You can open the Simulation Manager dialog box by simply clicking the Simulation Manager button. The details about the Simulation Manager dialog box will be explained later. Simulation Manager allows the simultaneous simulations of multiple cases faster than the normal DOE. I will now show you how much speed improvement has been achieved by the simultaneous simulations through Simulation Manager compared to the normal DOE. Let me talk about the DOE's speed improvement. In this table, the first row is the item, and the second row is the total analysis time. The third row is a speed improvement compared to normal DOE. In other words, when the normal DOE time is 1, the numbers in the third row means the multiples of how fast each simultaneous simulation using Simulation Manager took compared to the normal DOE. The second column is the total analysis time of the normal DOE run. From the third column to the eighth shows the results of DOE using Simulation Manager. As you see from the table, 1 run, 2 runs, 3 runs, and 4 runs are gradually getting faster. But from 5 runs and above, there is no big change. This phenomenon can be seen more clearly in the graph of total analysis time. It was confirmed that the analysis speed converges after 5 runs based on the red scale mark. In other words, performing 4 concurrent runs is the most effective, which is equal to the numbers of pieces cohorts.